All right, welcome to Chapter 7. And Section 7.1 here is on multiplication properties of exponents. So we're going to talk about exponents here. And kind of talk about multiplying monomials and simplifying expressions using these properties of exponents. So first, exponents. First thing we're going to talk about is what is an exponent? It's a base number and a power. Okay, a base number and it has a power to it. So an example would be like 5 to the third power. Okay, and you guys might know that in this case. It means you're multiplying the base by itself the power number of times. So this example up here would be 5 times itself 3 times. 5 times 5 times 5. And then when we talk about exponents, where with variables, like x to the 5th power would be x times x times x times x times x 5 times the base number times itself 5 times. Okay? Next up, what is a monomial? So real quickly what these are. Monomial is a number or a variable or a product of a number and one or more variables. Okay, notice there's not any addition, subtraction, or division listed there. It's a product. Either it's simply by itself or a product. So say like x to the 6th power, that would be an example of a monomial. You got a variable and a power there. 5x cubed, we've got a product, we've got a number, and we've got a variable. So that would be a product. And sometimes we get one, this is one or more variables, so we could have a, b cubed, a to b to the 3rd power. That would also be a monomial. We got products there. Okay, no addition, no subtraction, no division, just multiplication there. And what is a constant? Constants are monomials that are real numbers. So we talk about real numbers. If it's just a number, like an example would be the number 8 or the number -3. If it's just the number with no variable, then we call that a constant. We talked about those before. Okay. So determine whether these are monomials or not. So this first one, we should know right off the bat that this is a no because we've got this addition sign. We didn't say anything with addition. So because of that, we're going to go ahead and say no because it's got addition. And we only deal with multiplication there. This -5, we just talked about what a constant is. So yes, it is just the number. It is a monomial. How about letter C? We have ABC over 5. Now that looks like division, but remember, because there is no number in the numerator, you could actually write this as 1/5 ABC, which would then make it a product, multiplication of the fraction and the variables, so then we could say yes on that one. Letter D would also be yes, because we've got 2 variables and a number, but there's no addition or subtraction sign, it's just multiplication there, so it would be yes. Here, you can see that this has 2 variables in division. We can't really do what we did with letter C, so we would say no here because we would have to divide there. And the same thing on F, because this is in the denominator. Unlike over here, where our variable was in the numerator, and we could make it a 1 on top of it, here, because the variable's in the denominator, we're going to have to say no to this one as well. Okay? So very simple, explaining why yes and why or why not. All right, let's talk about some powers and their properties. So first, the product of the powers. So what we're going to do here, well, for each of these, there's an example of how to do it, and then there's a little shortcut. So let's show you the example first, and then we'll give you the shortcut. So if we said like x to the 3rd times x to the 4th, well, if you were to actually write this out, you would have, for this one here, you'd have x times x times x. And then in this one here, you'd have x times x times x times x, 4 of them. So how many x's would you have altogether? You would have 7 of them. So we could say that x to the 3rd times x to the 4th is x to the 7th. Well, the shortcut is basically saying take the exponent, keep the base, and add the exponents. So if the base is the same here, it is x and x, and we just add the exponents. 3 plus 4 gives us 7. That makes it a shortcut. If you're good with the shortcuts, use the shortcuts. It'll save you a lot of time. If not, you can write it out like this with x times x times x, and over here, x times itself 4 times, and then you'll always get the right answer. But if you get good with the shortcuts, it makes life a lot easier, a lot faster. How about a power of a power? So in this case, our example would be like something like x cubed all to the second power. That's a power to a power. Okay? So in this one, what we would do is we actually have to, what this is saying is because the 2 is outside this parentheses, it's saying everything inside the parentheses squared. So x cubed times x cubed. Or basically, it would be x times x times x. Let's rewrite that, basically, because what this is kind of saying is x cubed times x cubed, right? Because it's squared. So really what we're looking at is x times x times x, and then another x times x times x. So altogether we would have x to the 6th power. Because there are 6 of them. 1, 2, 3, 4, 5, 6. So altogether we have x to the 6th power. Well, our shortcut here is you're going to keep the base, just like we did in the first one, and now you're going to multiply the exponents. So you're going to keep this base number of x. That's going to stay the same. And then instead of adding like we did on this first example, we're actually multiplying the 3 times 2. 3 times 2 gives us 6. Okay? And the next one is a power of a product. Power of a product. So what that means is, now, in this example, we're going to have, say, a product is kind of similar to the first one, except now we've got a product in the parentheses. So we've got like 3x cubed, and then we're squaring it. So the only thing different here is now we've got a product here because it's 3 times x cubed. And the big thing here is if we were to write this one out, and then we'll show you the shortcut here, but if we were to write this one out, we would have, it's basically this whole thing squared, right? Because it's everything in parentheses squared because of the 2. So we'd have 3x cubed times 3x cubed is basically what we're looking at here. Okay? So if we did that, we would have, that would become 3 times x times x times x, because that's what 3x cubed would be. And then over here we'd have another 3 times x times x times x. So all together, in this one, we'd have to go 3 times 3, which is 9. 3 times 3 is 9. We're not adding it, we're multiplying. And then how many x's do we have? 1, 2, 3, 4, 5, 6. So it'd be x to the 6th power. Okay? Our shortcut here says distribute the exponents to each base. So we look at this one and we say, well, squared. Basically, you're going to square everything in the parentheses. So 3 squared is 9. That's 3 times 3. And then we can use our product to a product rule that we did up here and do it here as well. 3 times 2 is 6. 9x to the 6th power. So there are some little shortcuts. Again, if you don't like the shortcuts, write it out. Write it out will never fail you as long as you write out the right number of x's or the variables, whatever. But if the powers get so large, like say it's 3x to the 71st power, you don't want to write 3x 71 times. So that's why the shortcuts are good. So kind of study those and use them as we go. Now let's talk about simplifying an expression involving monomials. Write and then write an equivalent expression in which this happens. So each base appears only one time only. We don't have an x in the front of the monomial and then an x later. We just want one base, one x value. Okay? There are no powers of powers, so we can use our shortcuts to get rid of them. The third thing is that all fractions are in simplest form, of course, so you can reduce if you need to reduce. And the last one, any exponents are positive. And these last 2, 3, and 4, we'll talk about as the sections go on later in the chapter. But we'll talk more about fractions coming up. And then negative exponents we'll talk about in the next section as well. But we want to make sure they're all positive. That's our rule. Okay? So let's do a couple of these. So this first one, I'm going to do it the long way, and then we'll kind of look at the shortcut way and see how we get the correct answer. And actually, well, here's what I'm going to do. I'm going to do the shortcut way first, just to show you how it looks, and then I'll write it out. So we have 5x to the fourth times x squared. So in this case, there's no 5 in the second term here. So I can just multiply 5 times 1, which is 5. And then I can use my exponent rules. It's x to the fourth, x to the second. So I'm going to keep the base, x. I'm going to add the exponents. 4 plus 2 is 6. And that would be my answer, 5x to the 6th power. Okay? If you don't like the shortcut, let's write it out, see what it would look like. Okay? This first one would write out to be 5 times x times x times x times x. And this second one here would just be x times x. And since we're multiplying, we basically look at it and say, well, there's the 5. That goes with this. And then how many x's? 1, 2, 3, 4, 5, 6. X to the 6th power. So you can do it either way. The shortcut way is faster if you get that down. But if not, you can always write it out. Let's go to number 3 here. Number 3, r to the 4th, and then negative 12 r to the 3rd. Okay, again, I'm going to do the shortcut first, just because I like that one better. So we're looking at it. R has a 1 in front of it, so 1 times negative 12 is negative 12. And then here, we're just going to add our exponents. You got r to the 4th and r to the 3rd would add to make r to the 7th. You keep the base number r, and then you add the exponents. Okay, so let's make sure that that works out for us. This is the long way. We write it out. R to the 4th would be r times r times r times r. And then we're going to multiply here, negative 12, and then r 3 times r times r times r. So again, we're looking at, hey, there's nothing here to multiply with negative 12, so that's just going to go right up there. And then how many r's? 1, 2, 3, 4, 5, 6, 7. And that's how we get our answer to be negative 12r to the 7th. Okay? We'll have more practice problems that we can do. Here we go. Number 5. Number 5 is tricky because we've got a power to a power to a power. We'll leave that one for tomorrow. I like that one. But we'll leave that one for tomorrow in class. And then number 7 here. Let's try number 7 because we got ab squared times ab squared. But the difference is, where is the 2? In this case, the exponent is in the outside the parenthesis, which means everything inside the parenthesis, this whole ab is squared. And then the second one, it's ab squared with nothing outside the parentheses. So that's just saying that the b is the only thing squared there. Okay? So I'm going to do the shortcut again first, just to kind of look at it. Remember, if there's nothing in front above it, there's a 1 there. So how many a's do we have? We have basically a to the first, a to the first. So we're going to keep the base number a. We're going to add the exponents, and we'll get 2. Oh, I'm sorry. My bad. Because first thing we'd have to do, even before we did the shortcut, is we're going to have to square this one. We're going to make this a squared, b squared, and then we're going to multiply it by a b squared. So now when we multiply this one, you've got an a squared and an a to the 1st power, which is going to be a to the 3rd. In our b's, you've got b squared and b squared, so we're going to keep the base number b. We're going to add the exponents. 2 plus 2 is 4. Okay? And let's do that the long way just so we can show what it would look like. If we write it out, ab squared would actually be ab times ab. And then this one, ab squared, would just be a times b because the b is the only thing squared there. So now we can count up how many a's do we have. We have 1, 2, 3 a's, so that'd be a cubed. And then our b's, we have 1, 2, 3, 4 b's to make b cubed. Okay, so just be careful with the shortcuts when we're going through it. All right, that takes us to the end of it, lesson summary here. And I just want to know, with the lesson summary, what's easier for you, writing it out or using the shortcuts? And then tell me why. What helps you? What's giving you problems with the other way? And then simplify this one. 3x squared in parentheses, and then we're cubing that one. So it's kind of a power to a power there. All right. That is it for section 7.1. And we'll bring you questions. We'll rock and roll tomorrow.